Now, something to note while you're looking at that is I put like a little secret page in the middle of that foldable that had that nice factoring guide that we did back in the last unit. So, like, the flow chart that tells you where you start and where you go to based on certain conditions, as well as some examples. And then I also put a square root guide in here. We'll come back to that in a little bit, but I just wanted that to be kind of in the same place so you don't have to do a lot of flipping because again, factoring is fairly fresh, but you may still forgot some small parts of it. All right. So that's why I put that little factoring guide in the middle, just in case you need that reference. Now, we're going to talk about the factoring method to find zeros of quadratic equations. Now, the problem with this method is that it does not work on any quadratic. It only works if the quadratic equation is factorable. What I mean by that is, all right, for example, you don't need to write this part down. Say I had x squared plus 2x minus 1. Can you factor that? So we need two numbers that will subtract or will multiply to give us -1, but add to give us 2x. Is that possible? So we know our two factors have to be -1 and 1. Does -1 plus 1 give us 2x? No. That's still a quadratic. That still has solutions, but it is not factorable, so we can't use the factoring method. So this is actually an example of a non-factorable quadratic. So that's what I mean by when I say if the quadratic is factorable. Some quadratics are factorable, others are not. Factors are typically going to be like your very, very nice zeros. Like they're either going to be very simple fractions or whole numbers on a graph. All right. Now, finding zeros by factoring is also known as solving a quadratic equation. So this is one of the methods for solving a quadratic equation. And just to note that if a quadratic cannot be factored, that does not mean that it has zero zeros or zero solutions or no solution. It can still have solutions. They're just not pretty. They may be radicals or they may not even be real solutions, which you won't really learn about until next year in Math 2. So again, if it can't be factored, the answer is not no solution. It just means you got to use another technique. And again, you're not going to see many like that in this class, in this case. All right. So steps for finding the zeros by factoring. The first thing, and this is probably the most important thing, get the equation so one side of the equation is equal to 0. Anytime you start any quadratic equation for solving any quadratic equation, you always want one side to equal to 0. So that means you want to look like ax squared plus bx plus c is equal to 0. You always want one side equal to 0. You will see that step in almost every strategy that we work with, both in this class and in Math 2. Then we're going to put it in standard form if it is not already. So remember, standard form is essentially this form right here. So the x squared comes first, then the x, then the constant. Then we factor the equation. So again, that's stuff from Unit 7. So you can refer to Unit 7 or the flow chart on the previous page. So the factoring side of this, we're actually not going to take a whole lot of time on because you should be fairly proficient at this now. Then we're going to set the factors equal to 0 individually. So what that would look like is if I had two factors, I would set one equal to 0 and then the second one equal to 0. So essentially you're breaking the two factors apart once you get them and you're setting them equal to 0, creating what I like to call mini equations. Because then what you're going to do is solve those mini equations. So you're going to solve each mini equation for x, and that'll give you the zeros. So the great thing about solving by factoring is that once you factor it, you basically have two little mini linear equations that you can solve, and they're usually like 1 or 2 step equations. They're usually not very complicated. A lot of times you can eyeball them and get the answer. All right. Now, this is important. If you factor out a numerical GCF, remember, you always look for a GCF first. If you factor out that numerical GCF, you do not need to set that GCF equal to 0. It kind of goes away. But if you factor out a variable GCF, meaning like if you factored out an x, you must set it equal to 0 and solve. All right. So a quick example would be, say I had, let's do some like two little quick examples. So say I factored an equation, I got 2 times x plus 1 times x minus 1 is equal to 0. All right, that was after I factored. What happens is that since this 2 is here, we would technically divide both sides by 2 to get rid of it, but 0 divided by anything is always what? 0. So essentially this 2 just goes bye-bye. And then we do x plus 1 equal to 0, x minus 1 equal to 0 to get our answers. On the other hand, if I had x times x plus 1, so I factor down x, that equals 0. That x is still a variable and it is part of our solving. So what happens is that we would have x equal to 0 because we got to set that variable equal to 0. And then x plus 1 equal to 0. So all that means is that 0 is actually one of your zeros. So if you have a numerical GCF, you can just cross it out. It goes away if you're solving. Only if you're solving. If I tell you to factor, that's a different matter. If you have a variable GCF, you have to set equal to 0 and solve. All right. So let's do some examples. So example 4, we're going to find the zeros of the quadratic by factoring. So my first step is I need to get one side equal to 0. So in other words, I need to use inverse operations, like if we're solving a linear equation, to move something over to the other side of the equal sign to give us 0. So if I do that, what do you think I should move to the other side to get 0 on one side? What would be the easiest thing to move? Say it again. Not the 3. I need one side equal to 0. The 6. How would I move the 6? So if you were solving an equation, you would subtract the 6 to the other side. And make sure you're subtracting it to its like term. So we will subtract the 6 to the negative 12. So we are going to subtract that 6 because it's the only thing on this side. So since it's alone, that's going to be the easiest thing to move to get one side equal to 0. Because now what happens is that these two cancel out, and I now have n squared plus 3n minus negative 12 minus 6 is negative 18 is equal to 0. Guys, heads up, please. Come on. Now, once I get one side equal to 0, I'm now going to factor the trinomial. So walk me through it. What's my first step? So guys, this is Unit 7 review. What's your first step when you're doing this? Big X. Good. So we're going to do big X. Remember, A times C goes on top and B goes on bottom. So what goes on the top? Not just 18, but negative 18. So if you labeled everything A, B, and C in that order, A times C is 1 times negative 18, which gives you negative 18. Guys, this is a review from last unit. We did a whole lot of factoring practice. And what's my B value? 3. So what are two factors of 18? So two numbers that multiply to negative 18 but add a 3. First off, if we're multiplying to a negative number, that means one of our factors has to be what? Negative. So one of them has to be negative. So what are some factors of 18? Someone give me a factor of 18. So I heard 1 and 18, I heard 2 and 9, and I heard 6 and 3, or 3 and 6. If I made one of those sets, if I made one of the numbers in one of those sets negative, which one could potentially subtract to give me 3? It's 3 and 6. Now, since I'm going for a positive 3, which one has to be negative? The 3. So my two factors are 3 and 6, or negative 3 and 6. Now, the next step would typically be your reverse box. So, but there is no, I'm not going to go through that. So, if I'm just setting up my reverse box, remember, you're replacing your n value or the 3n with these two values. So, we always have n squared in the corner, negative 18 in the top bottom right, and then we can have negative 3n and 6n. So I have n times n gives me n squared. What times n gives me negative 3n? Negative 3. What times 6 gives me 6n? Or what I basically just said, it's positive 6. So these are my two factors. So I get n plus 6 times n minus 3 is equal to 0. Now, my last step is to break apart these two factors and set both factors equal to 0 and solve. So I'm making my two mini equations. So I have n plus 6 equals 0, n minus 3 equals 0. And I'm going to solve it. So what's the only thing I have to do to solve n plus 6 to get n? What's the only thing I got to do to solve for n plus 6 equals 0? Minus the 6. So if I subtract 6's to both sides, n is equal to negative 6. What's the only thing I got to do for n minus 3 equals 0 to solve? Add the 3 to both sides. So n is equal to 3. So my answer, if I write it in the set notation, n is equal to the set of negative 6, comma 3. So that means that on my graph, my x-intercepts would be at the point negative 6, 0, and at the point 3, 0. Also, if I plugged in negative 6 and 3 back in for n in my original equation, it would equal 6 if I evaluated. So they are solutions to this equation right here. Any questions on that? All right, let's try another one. All right, So first thing I got to do, get one side equal to 0. So let's go with Ralph. What's the only thing I got to move to get one side equal to 0? What will be the easiest? Right, the negative 7 is probably going to be the easiest to move. How would I move it to the other side? We add it. So I'm going to add the 7 to both sides. Now, since there's no constant to add the 7 to, I'm going to assume that it doesn't combine any like terms. So we're just going to write it out as 7r squared minus 14r plus 7 equals 0. Because is 7 a like term to 7r squared? Yes or no? Does that have the same variable, same exponent? The 7 and the 7r squared. Come on, guys, give me something. No. What about the negative 14r and the 7? Are they like terms? No. So since none of them are like terms, I just add on the 7 at the end. Now, what's my next step for factoring? What's the first thing that I always look for when I factor? What do I always look for first? Anyone remember? What do you always look for first when you factor anything? Look back at that flow chart on the previous page if you need to. Guys, you got to put the heads up. A GCF. So, all you with your heads up, put them up. Come on. So, we're looking for a GCF first. So, what is my GCF that you can see? Riley M. What do you think that GCF is of my trinomial? So, what number or value could go into all three of those terms evenly? 7. So, my GCF is possibly 7, which it is. So, I'm going to divide all my terms by 7. So, I have 7 on the outside. So, this would be r squared minus 2r plus 1 is equal to 0. Now, what did I say you can do about numerical GCF? So what can you do with that numerical GCF? Not distribute, because that'll just give us what we started with. Look at the top of your notes for this page. What does it say to do with a numerical GCF? I'll give you a hint. It's in bold letters at the very bottom of the top section. So guys, right here, numerical GCF. It's technically a factor, but what does it say I need to do with it? It's in pink. Say it one more time. You don't need to set it equal to 0. You can just cross it out. It's not relevant. So this goes away. So all we need to do is just factor this trinomial. And I'm going to do a quick factor of this. So your a times c value is 1. Your b value is negative 2. What are two values or factors of 1 that add to negative 2? 1 times 1. And since we're looking for a negative 2, they both need to be negative. So we have negative 1 times negative 1. So without even doing a big reverse box, because my a value is 1 in this case, my two factors are r minus 1 times r minus 1 is equal to 0. Now, is it true that both of these are the exact same expression? Yes. So since they're the exact same expression, we only need to set one of them equal to 0, because what that means is that we only have one solution in this case. So we're only going to bring down one of the r minus 1 equal to 0 and solve. So we would just add 1 to both sides, and r would be equal to 1. And that would be our only solution. So the way you get one solution in this case, so this particular quadratic only has one solution instead of two. The way you would get one solution is if you have the exact same expression after you factor. So both your factors are the exact same factor. That's how you end up with one solution. And if you did set both of them equal to 0, you would still have gotten r equals 1 for both of them. But the way sets work is that you don't need to restate the same number twice. So in reality, r is just equal to 1. So it would only cross the x-axis once. All right. 2 more and then we'll take a break. So we need one side equal to 0. This one's a little bit more tricky. My suggestion to you is you always want your x squared value to be positive. So you always want the x squared value to be positive. It just makes your factoring a lot easier if that x squared value or k squared or whatever is positive. So what do you think? Which side do you think I should start moving from, the left or the right, to make the k squared positive? So in other words, should I move the 4k squared to the right or the negative 5k squared to the left? We would move the negative 5k squared to the left. So I would add 5k squared to both sides. So that goes away. I get not negative 4k. I get 1k squared minus 8k minus 3 is equal to negative 3. Then what's my last step to get one side equal to 0? Add 3 to both sides. So I'm going to add this 3 to both sides. So that goes away. And in reality, this goes away too because negative 3 plus 3 is 0. So this is k squared minus 8k is equal to 0. So that being said, this factor is really easy to do because all we have to do is factor out a what? We just got to factor out a GCF. What is that GCF? K. So we're going to factor out a GCF of k. So I'm going to divide both of these by k. So what's k squared divided by k? So if I take 1k away from 2k's, just k. And then these 2k's cancel because k divided by k is 1. So I have minus 8 equals 0. Now, I have a variable GCF. What does it say I have to do with that variable GCF up top? We got to set it equal to 0. It's part of my answer. So I'm going to set both of these factors equal to 0, including the k. So k is equal to 0, and k minus 8 is equal to 0. Well, guess what? One of them's already solved. One of your answers is going to be k is equal to 0. You don't have to do anything else with that. But the other one, what's the only thing we got to do to solve? Add the 8 to both sides. So k is equal to 8. So my answer is k is equal to the set of 0 and 8. All right, last one, then we'll take a break. So, example 7. What's the only thing I got to do to get one side equal to 0? Subtract that 5 to the other side. So, guys, my suggestion to you, sometimes the easiest one to move is the one with the least amount of terms. All right. So, example 6 was kind of hard in terms of because you had to move 2 things over to the other side, but it still had less terms than the left side. But when in doubt, if it's just a number on one side, move that number to equal 0. That's the easiest thing you can do. So this would be 3r squared minus 16r minus 12 is equal to 0. Now, I now need to factor this trinomial. Are there any GCFs, first off, that we can tell? You sure? So we know 3 and 12 are like terms. But does 16 have anything in common with 3 specifically? No. 3 cannot go into 16. And since 3 is a prime number, it only goes into 1 and 3, we don't have a GCF. All right. Now, guys, a little trick for if you ever have trouble finding the GCF. Desmos is a beautiful thing. So if this was on the calculator active section, Desmos can actually find a GCF for you. It can't find a variable GCF, but can sure as heck find a numerical one. So all you do is just hit the keyboard and you go to functions and you scroll all the way down until it says number theory. Then you're going to click the one that says GCD. So it's the one on the very top row in the middle. GCD stands for greatest common denominator, which is the exact same thing as a greatest common factor. So if you click GCD, this will pop up. And all you do is type in your numbers separate by a comma. So 3, 16, 12. And right there, this number right here, or in the bottom right corner, 1, that's actually the GCF. So if the GCF is 1, then there's no GCF. But you can do that for any number. Say I turn this 16 into an 18. GCF is 3. Especially when you have some really big numbers and you don't know the GCFs off the top of your head, that is a tool that you can use, especially if you're on the calculator active section. All right. So that's just kind of a trick that can help you guys out a little bit. Now, since there's no GCF, we go right into big X. So A times C is on top, B is on the bottom. So what's A times C in this case? Someone besides Olivia. She's been carrying y'all today. So if I label A, B, C, what's A times C? Negative 36. Good. What's my B value? Negative 16. So I need 2 numbers that multiply to negative 36, but add to negative 16. So that means that one of the numbers is going to be negative since we're multiplying to get a negative number. So what are some factors of 36? Someone name me one factor of 36. 6 and 6. So we have 1 and 36. 6 and 6. What else? 9 and 4. What else? 3 and 12. One more. 36 is even, right? Meaning it can automatically be divided by 2. So what's 36 divided by 2? 18. Now, if I made one of those numbers negative in the set, which one or which set could potentially subtract to give us negative 16? 2 and 18. And then which one would have to be negative? The 18, since it's negative 16. So this will be 18. This will be 2. Now, you definitely have to do a reverse box for this one. So I'm going to write R after these two. So I have 3R squared and then negative 12 in the bottom right. And I'm going to put negative 18R here and 2R here. Now remember, when your A value is greater than 1, meaning you have something in front of the R squared, you got to kind of do a little bit of out-of-the-box thinking when you do a reverse box. What's the only thing that I can multiply to give me 3R squared? So what are the two factors of 3R squared that I need? 3R and R. So we're going to do 3R times R to give us 3R squared. Now, this is where the placement comes in. So it can either go here or here. If I put the 3R on top, is there any number I can multiply to that 3R to give me 2R? No. So by process of elimination, I would have to put the 3R here because 3R times a number does give me negative 18. So that means the R has to go here. So 3R times what gives me negative 18R? Negative 6. And then R times what gives me 2R? Positive 2. So these are my two factors. So my two factors are 3R plus 2 times R minus 6 is equal to 0. So then I set both of these equal to 0. So 3R plus 2 is equal to 0. R minus 6 is equal to 0. Separated the two. Now, R minus 6 is easy. It's just that one-step equation. You just add 6 to both sides. So R is equal to 6. But 3R plus 2 is a two-step equation because we have something connected to the R. So what's my first step? Subtract the 2. You always get rid of the constant first. So I have 3R is equal to negative 2. And then what's my last step? Divide by 3. So R is equal to negative 2/3. So my answer would be R is equal to the set of negative 2/3 and 6. So that's why I said sometimes your factors give you a nice fraction. That's an example of one of your factors giving you a nice fraction. It was a two-step equation. Any questions on solving by factoring? All right, we're going to go ahead and take our 5-minute break. If you need to use the restroom, go ahead and do so. You need to be back in this room by the time this timer goes off. So all my little sleepyheads, y'all need to be awake by the time this timer goes off. All right, guys. My beds are up, so all my heads should be up. All right. So the last section's a lot shorter than the factoring. It's just solving by taking a square root. So we're just going to go ahead and knock it out, just so you guys can go ahead and finish that delta math that I assigned you yesterday. So the last section of this foldable is how to solve by taking a square root. All right. This one's a um, relatively easy strategy for simply because it's almost like just solving regular linear equations. There's just like one extra step, which is that square root aspect. All right. You're still doing inverse operations. You're still doing moving things around the equal sign. That's pretty much all this method is. But there is a constraint to this method. So when you're solving a quadratic equation by taking a square root, it's another method to find the zeros or the x-intercepts. And like I said, it's very similar to solving linear equations, but just has that extra step of taking that square root to undo the square. So remember, x squared, if you take a square root of x squared, that's equal to x. All right. So remember, that's what we're trying to do. We're trying to just get x. So at some point in our method, we're going to have to take a square root. Now, this method, here's the constraint. This method can only be used if there is no bx value. So remember, when you have x squared, ax squared plus bx plus c, this bx cannot be there in order for you to use the square root. So you can't already have an x value in there. You can only have an x squared and a constant. So it should look like ax squared plus c. That's what you're looking for if you want to use the square root method. If it has an x already in there, not just an x squared, then you can't use this method. All right. Now, your steps for finding these zeros. The very first thing is you need to identify your squared variable or squared set, because the goal is to get the squared variable by itself before you can take a square root. So taking a square root should be like one of the last steps. It's not always the last step, but it is one of the last steps, usually. All right. Then you just solve it like a simple equation. You add or subtract any constants to both sides of the equal sign. You multiply, divide, or any coefficients to both sides of the equal sign. Remember, that's inverse operation. So if it was adding originally, you subtract it. If it was multiplying originally, you would divide it. All right, that's review from last semester. Then we take a square root of both sides at some point of the equal sign to cancel out the exponent connected to the variable. All right. Now, whatever our answer is, this is the most important part. Whatever your answer is, you need to write your answer with a plus or minus sign in front of it. So that plus or minus sign. Why do you think I need to write my answer with a plus or minus sign? For example, if I took the square root of 4, what's the square root of 4? So you're undoing a square. What's the square root of 4? 2. In reality, the square root of 4 is plus or minus 2. Why is the square root of 4 plus or minus 2? So plus or minus is another way to say that that number can either be positive or negative and still be our answer. So the square root of 4 is equal to 2. It's also equal to negative 2. Why is that true? So we know 2 squared is equal to 4. But what's negative 2 squared equal to? What's negative 2 times negative 2, guys? Positive 4. So if you take the square root of a positive number, we don't know for sure whether our answer is the positive version of that number or the negative version of that number. For example, the square root of 9 is plus or minus 3. Square root of 16 is plus or minus 4. Because the positive version of that number and the negative version of that number squared could equal our original number. All right. That's why I gave you that little square root chart up top, because it explains that both the positive version and the negative version of the number can give you the exact same perfect square. All right. So, for example, 6 times 6 or negative 6 times 6 can give us 36. That's why the square root of 36 is plus or minus 6. That's why we always put a plus or minus in front of these. We're accounting for the fact that our answer could be either the positive version or the negative version. All right. Technically, it's like a 2-in-1 combo. We're technically only going to be solving for one thing, we're only going to be solving technically for one number, but by adding that plus and minus, we got both our answers because they are two separate answers. All right. Now, a couple things to note. If your number is not a perfect square, leave it as a square root, or I guess this got cut off, round if necessary. So in other words, if it asks you to put in your calculator in round, you put in your calculator in round. Otherwise, you just leave it as the square root of whatever number. And then, of course, like I just said, you always got to write that plus or minus sign in front of your answer. I will tell you right now, if this was on the test and you did not write plus or minus, it would be wrong. Same thing with your delta math. If you did not put that plus or minus in front of it, it would be counted wrong. All right, let's do some examples. So, example 8. What's our squared value? Where's my variable that's squared? K squared. Guys, if you got AirPods in your ears, please take them out. So, that's my K squared. Is it already by itself on that side of the equal sign? Yes, no, maybe? Yes. So we can go ahead and take a square root of both sides. Because what happens is the square and the square root cancel each other out, and it just leaves us with a K is equal to. Now, do you think 76 is a perfect square? Meaning it has a nice number when you take the square root of it? You sure? No, it'll give you a really weird decimal. So we would leave our answer as the square root of 76, but we always got to slap a what in front of it? Plus or minus. And that plus or minus goes outside the radical symbol. Don't put it with the 76 on the inside. Put it outside the radical symbol. And there's a reason for that, which we'll talk about in the next example. So K is equal to plus or minus 76. Now, this is what we call our exact answer. Meaning that that's the actual answer. That's the actual number that gives us our answer. Now, if I asked you to give me a rounded answer, let's just say round to the nearest hundredth or 2 decimal places, I would just put in my calculator, so you can either do a TI or Desmos, but since I already have Desmos up, I'm just going to use Desmos. So I'm going to type in square root of 76, and I'll get 8.72 if I rounded. So K would be approximately, remember the squiggle equal sign means approximate, plus or minus 8.72. So this is my approximate answer. Both are correct. It just depends on what I would ask for. When in doubt, give me the exact. Only round if it tells you to round. All right. So when in doubt, give me that exact answer. All right. But both of these are acceptable answers. But again, when in doubt, give me that exact answer. All right. Any questions on that one? Now let's look at one that we got to do a little bit more work to. So first off, what is my squared variable? Not 2n squared, just n squared. So remember, if this was 2n all squared, then yeah, that's our squared variable. However, since the 2n is not in parentheses, that squared is only connected to the n. So that's the variable we're trying to get by itself before we take a square root. So before I take a square root, what do I need to do to get that n squared by itself? Divide the 2 to both sides. So that's why I tell you guys to identify your squared variable, because more often than not, I get a lot of students that would go ahead and take a square root if they get down to that. All right. Make sure that if there's no parentheses around the number with the variable and it's squared on the outside, that you do not take a square root until you get rid of that number connected to the n squared. All right. So this would be n squared is equal to negative, not negative 12, we're just dividing it by 2. I don't feel like doing this off the top of my head. So 144 divided by 2, 72. So negative 72. Now, our last step is to take that square root. So I'm taking a square root of both sides. Now, here's where it gets a little wonky. Real quick, if you have Desmos up or if you have a calculator, so I want everyone to grab a calculator right now, just for this one moment. I want you to put in what the square root of negative 72 is. So I want everyone to put in what the square root of negative 72 is. So what's the square root of negative 72? Do you get like a weird decimal or anything? What does it say when you put in the next square root of negative 72? Error. So if you put in the square root of negative 72, you get an error message. And look what it says. What does it say when it says error? Non-real answer. All right. If you put it in Desmos, you'll get something similar. Square root of negative 72, undefined. All right. When you get to math 2, you will learn that this is what we call a complex or imaginary answer. All right. So this will be an example of on the graph, it's technically no solution. It doesn't cross the x-axis. However, we don't just state that it's no solution. We state that it's no real solution. Because if you ever have a negative under that radical sign, if you have a negative under the radical, your answer is automatically this. And even if you put in your calculator, you will get the same thing. If you ever have a negative under your radical, it's automatic, just under the radical. It's automatically no real solution. So, because again, you'll learn what this is more about in math 2, but if you're curious of why that is, it's because in the realm of real numbers is actually not the biggest umbrella that numbers fall under. The biggest umbrella that numbers fall under in math is complex numbers. And complex numbers is separated into 2 categories, real and imaginary. Yes, there are imaginary numbers in math. All right. You will learn more about this in math 2. Basically, what happens is that this particular quadratic will have an imaginary solution. And yeah, it's weird, but it's just something that some mathematician back in the day came up with. But essentially, there's no actual real number solution. So that's all you got to state. If you have a negative under that radical, your answer is automatically no real solution. You don't even have to put in your calculator. It's just no real solution. That's why you get that error message, because your calculator can only deal with real numbers. All right. This one. Here's my x squared value. What's the only thing I got to do to get that x squared by itself? Subtract an 8 to both sides. That goes away. X squared is equal to 20. Take the square root of both sides. That goes away. X is equal to the plus or minus the square root of 20. So that's our exact answer. My approximate answer will be plus or minus what? Put in your calculator. What's the square root of 20? So round it to the nearest hundredth, so 2 decimal places. So guys, put in your calculator. What's the square root of 20? Say it again. 4.47? Good. So this will be approximately plus or minus 4.47. So again, this is the exact. This is the approximate.
So you're not even starting with problems today.
No. God, no. So this last one, where's my squared value? What is it? It's just n squared. So it's almost like we're solving a two-step equation here, like we did in the last semester with linear equations, before we have to take a square root. So what's my first step if I'm using inverse operations? Plus 7. So that goes away. I get 5n squared is equal to 495. All right. Now, n squared is still what we're trying to get by itself. So highlight it, underline it, whatever you need to do to know that that's what you got to get by itself before you take a square root. All right. So what do I have to do next to get the n squared by itself? Divide both sides by 5. We got to get rid of that 5. So n squared is equal to what? 99. And then what's my last step? Square root both sides. This goes away. N is equal to plus or minus the square root of 99, because 99 is not a perfect square. Which, if you put in your calculator, n is approximately what? Say it again. 9.95. So plus or minus 9.95. That's the exact, and that's the approximate. Now, this is not our last example because I want to do one more on one that you're going to see in your Delta math. It's a little bit harder, and I forgot to add this when I was making the notes. So that's on me, but just write it wherever you have space. I wouldn't really write on the back because remember, you do have to glue this down. So just write it if you have a little extra space somewhere. Or even if it's somewhere in your journal. So if you already have it glued into your journal, you may want to write this somewhere off to the side of your journal. So we're going to call this example 12. So write down that problem. This is one that you'll see on your Delta math. Now, let's identify my squared value. Where is my squared value? So where's the squared anyway? What's it connected to? The parentheses. So that means that this is my squared value. This is what I want to get by itself before I take a square root. So this is one of the cases where your square root is actually not your last step. All right. So what do you think? Think about it in terms of like if you replace this with an x. All right. So it'd be like an x squared. What would be your first step? Nope. You do not distribute if you have a square outside of here. We're going to pretend like that's just an x squared. Forget about the x plus 7. Imagine that there's an x there. What will be your first step? It's basically what we've been doing. So imagine that's what's highlighted is your variable that you're trying to get by itself. So don't worry about the x plus 7 in there. We'll deal with that in a second. I'm just worried about what's outside of it. So what's the operation happening here? That's multiplication. What's the operation happening here to my variable or to my squared value? Subtraction. When we solve any equation, what do we always get rid of first? We would add the 35 to both sides. We would get rid of the constant. So that goes away. I get 4 times x plus 7 all squared is equal to positive. Can someone do 35 minus 19 in their calculator for me real quick? 16. Okay. Now, we're still saying that this is what we're trying to get by itself. So we're trying to get that highlighted portion by itself. So we got to get rid of the 4. How do we get rid of the 4? We divide by 4. So this would be x plus 7 all squared is equal to 4. Now, here's where it gets a little wonky for some people. Your next gut feeling will probably be to subtract that 7 over. You cannot do that. For the sheer fact that since it's in parentheses and it's squared on the outside, this x plus 7 is an exclusive relationship where it's married until you get rid of that square. The squares being the third wheel, you got to get rid of it before you can separate the other two. All right. So we got to get rid of the squared first. So we're going to take a square root of both sides. Because what happens is that the squared goes away. So I'm left with x plus 7. And then what's the square root of 4? Not just 2. What do I always put in front of my answer for a square root? Plus minus 2. Now, our last part to get the x by itself will be to do what? Subtract the 7. And I'm going to show you how to handle this in a second. So x is equal to plus or minus 2 minus 7. So what we have to do now is break apart the plus or minus 2 into 2 separate expressions. So we're going to have positive 2 minus 7 and negative 2 minus 7. So what's positive 2 minus 7 equal to? Negative 5. What's negative 2 minus 7 equal to? In other words, what's negative 9? So these are actually my two answers. So these right here are my two answers. So in reality, x is equal to the set of negative 9 and negative 5. Those are my two zeros. So if you see one of these on your Delta Math, which you can see it on your Delta Math, don't be thrown by it. That's why I say identify where your square is and highlight or underline it, because that's what you need to get alone or by itself before you can take that square root. All right? If your x value is being added or multiplied or subtracted inside the parentheses with the squared, do not touch it until after you take that square root. All right, but you've got to get everything else outside of that square to the other side of the equal sign. Any questions? All right, so you only got about 20 minutes left of class, so that's plenty of time for you guys to start finishing up the rest of that Delta math from yesterday. You should be able to finish it now. Now, one last thing. So, it has come to my attention that, and it may not be y'all in this class, but I have been told by administration that other teachers have been complaining about me because they're saying that you guys, and not you guys as a whole, but there's certain people, and I don't know who they are, but there's certain people that are saying that they can use their phones, or saying that since Miss Murphy lets them use it, that they should use it. So because of that, and again, it may not even be anyone